Hi everyone, this is Giri, lecturer in physics. In this video, we discuss about the dielectric, dielectrics in electrostatics and its properties. So this is the topic in this video. So welcome to Expertisor Academy. So this is our academy, Expertisor Academy. Okay. So the first thing, so what is the meaning of dielectrics or insulators? So the main thing in dielectrics is there is no any free electrons in this dielectrics. There is no any free electrons. Okay, and these electrons are not moving freely, are not moving freely because these charges are bonded with atoms. But external electric field, I mean battery, is connected with dielectrics. The alignment of the charges in these dielectrics are in different ways. So based upon that, dielectrics is made up of either polar molecules or non-polar molecules. Polar molecules or non-polar molecules. So the first thing is non-polar molecules. So what is the meaning of non-polar molecules and how to align the charges in these non-polar molecules when you connect the external field. Okay. A non-polar molecule is one in which centers of positive and negative charges coincide. Centers of positive and negative charges coincide. So this meaning is in the insulator there is a positive and negative charges. Both of these centers coincide like this. As a result, it has no permanent dipole moment. Example of non-polar molecules are hydrogen, oxygen, carbon dioxide, etc. Okay. When an external electric field applied, centers of positive and negative charges separated by a small distance, which includes dipole moment in the direction of the external electric field. Look at here, E is equal to 0. There is no application of the electric field. This is the alignment of the positive and negative charges. When you apply the electric field, that means E is not equal to 0. The distance in between positive and negative charges is created. Some distance is created between these two charges. The direction of the dipole moment when you apply the electric field towards the or parallel to the external electric field. Then the dielectric is said to be polarized by external electric field. So polarization means dipole moment per volume. Dipole moment per volume. So that is the polarization. So that materials are polarized. Okay. This is the dielectrics insulators. Dielectrics and insulator, first one. Okay. That is non-polar molecules. Next, polar molecules. In polar molecules, the centers of the positive and negative charges are separated even in the absence of an external electric field. Centers of positive and negative charges are separated even in the without application of the external electric field. See here, polar molecules are randomly oriented in the absence of an external electric field. So this is the polar molecules are separated. That means plus and minus. They have a distance between them. Okay. Next. They have a permanent dipole moment. Due to thermal motion, the direction of each dipole moment is oriented normally. So that means randomly. So randomly means different directions for different molecules. Okay. Hence, the net dipole moment is zero in the absence of external electric field. Examples of polar molecules are water, nitrogen oxide, HCl, and NH3. H2O, N2O, HCl, NH3. Okay. When you apply the external electric field, when an external electric field is applied, the dipoles inside the material tend to align the direction of the external field, external electric field. See here, this is the alignment of the polar molecules. This is the direction of the external electric field. External electric field. Okay. Hence, a net dipole moment is induced in it. Then the dielectric is said to be polarized by an external electric field. So here, these molecules are polarized by external electric field. When an external electric field is applied, the molecules partially align with the field. Partially align with the field. So here this is the negative charges alignment. This is the positive charges alignment in one way. Okay. So this is the polar and non-polar for dielectric materials. Coming to the polarization, there is a small definition for this. Polarization P is defined as the total dipole moment per unit volume of the dielectric. Total dipole moment per unit volume of the dielectric. So that is called polarization. This is small definition for this. Next topic in this. Induced electric field inside the dielectric. There is a induced electric field inside the dielectric. What happens? So what is that property? When an external electric field is applied on a conductor, the charges are aligned in such a way that an internal electric field is created, which cancels the external electric field. External electric field cancels the internal electric field. So that is in conductors. But in the case of dielectric, which has no free electrons, the external electric field only realigns the charges so that an internal electric field is produced. In conductors, internal electric field is cancelled by external electric field. In this dielectrics, internal electric field is created by external electric field. So that is the induced electric field inside the dielectrics. Next, dielectric strength. Dielectric strength. See that when the external electric field is applied to a dielectric is very large, it tears the atoms apart so that the bound charges become free charges. Very large amount of electric field is applied to the dielectrics. The bounded charges to the atoms are separated. Then the dielectric starts to conduct electricity. This is called dielectric breakdown. The maximum electric field the dielectric can withstand before it. Stand before it breakdown is called dielectric strength. When the charges which are bounded with atoms they are break down when you apply the external electric field. Before starting this process, before that process, the strength of the dielectric is measured. The strength of the dielectric is measured. So given this, see this one, substance dielectric strength, mica 100 into 10 power 6, Teflon 60 into 10 power 6, paper 16 into 10 power 6, air 3 into 10 power 6, pipes glass 14 into 10 power 6, volt per meter. Volt per meter is the dielectric strength, SI units. So this is the information about the dielectric, polar and non-polar molecules, at the same time polarization, induced electric field inside the dielectrics, and dielectric strength. So thanks for watching this video. For more videos, visit www.expertisoracademy.com. Thanks.